Have you ever wished for an AI that doesn't just sound smart, but actually understands your business inside out? Today, I'm going to show you how to build applications that combine the power of AI with your business domain data. So it's called Retrieval-Augmented Generation or RAG, and trust me, it's a game changer. By end of this video, you will know exactly how to use RAG to unlock your business full potential with precision, accuracy, and real-time insights. So let's get started. So in today's agenda, let's kick things off by talking about why RAG actually matters to us. The Retrieval Augmented Generation, also known as RAG, is not just another AI buzzword. It's a powerful framework that lets you combine the intelligence of large language models with your private data. This is where AI gets really interesting. We'll see how, with just few lines of code, we can implement the entire RAG application on a construction domain data using OpenAI's LangChain. So let's see what does it take to train a specialized AI model. And don't confuse yourself when I say models. I'm not talking about these chat applications like ChatGPT, Gemini, or Claude. I'm actually talking about the models that are running behind these apps. For example, when you go into any of their API documentation pages, you can see this list of models they provide. For instance, OpenAI has these base models like GPT series 3.5, 4, 4.0, and their latest 4.1. Google also has this Gamma, Gemini 1.5, and their latest Gemini 2.0 Flash. Anthropic Cloud AI has these base models, and Meta has their own Llama series, and Microsoft also has their own model as Pi 3. We also got a couple of models from Mistral AI as well, if we see here. And in 2024, Elon Musk's AI company XAI has open sourced their own this Grok model. So the list continues, and there is always a tough competition between these top companies to build a superior model. And note that some of these models are open source and most of them are closed, which means you need to pay them if you have to use their models. Going back to slides, let's see what does it take to build your own customized large language model from scratch, which understands the natural language and also has knowledge about your domain data hosted somewhere in your private network. First of all, you would need an enormous amount of good quality data. And then you need to build this complex model architecture. The image here depicts a simplest architecture of a deep learning neural network. If I have to explain this, then it itself will take an entire video. So we'll keep this for another time. But to give you a quick background, the reason it's known as deep neural network is because it has these nodes, also called as neurons, similar to our human brain cells, and they are connected to each other with these multiple layers. So this is the input layer and these are the output, and in between it got these multiple hidden layers. That's why it's referred as deep. To start with, each node is assigned with a weight and a bias that controls the final output of this model. So every time an output is generated, it is compared against the expected output, and if the generated output doesn't match with the expected output, the error difference is backpropagated, and then these nodes auto-adjust its weights and biases to generate the right results next time. And this cycle goes on and on for days together, and for sometimes even months to completely train this model. So that's how these large language models has learned about the entire corpus of internet data and able to predict the right results or response whenever we ask for any prompts. So that's why to build such complex models, you might also need some experts who knows about how to build these models and fine-tune these models to get the desired results. And with all this, we are forgetting something, that these models are nothing but software programs and they need some hardware to run on, because it's such a compute intensive task and having just CPUs is not enough. So we need some special hardware chips like GPUs that has large number of cores, which makes these programs to run in parallel and faster. Also, to run these GPUs, you would need an immense amount of energy resource, as this training goes on and on for days. So building a large language model from scratch is such a costly effort, right? Well, you might ask, Deepak, We can host these models on any of these cloud providers like AWS, GCP, or Azure, right? Yeah, that's true. Nowadays, there are many cloud providers coming up with many services to host these models on their infrastructure, like AWS, Bedrock, Google's Vertex AI, and even Azure has its own. But still, you need to pay a lot for these services. That's why, you don't need to start building these LLMs from scratch. As we saw earlier, nowadays you find many of these off-the-shelf pre-trained LLM models, and most of them are good at summarizing a text, generating an email response, and even solving a math problem. But in this case, it gave a wrong answer. So don't just blindly believe whatever AI says. So use your common sense. So one of the main limitations of these LLMs is they have no idea about our domain-specific data, which might be residing somewhere in our private network, right? The main reason behind is as it has not seen this data during its training phase, it has no clue if you ask something specific to your domain. For example, things like patients' medical records or clinical research data, or it could be something as a banking transaction if it comes to the financial domain, or credit card reports, or maybe real-time trading data. So another biggest disadvantage I can see with the LLMs is the knowledge cutoff. So what I mean is these LLMs lack the awareness of recent events or facts or even development that has occurred after the training phase has ended. So for example, if you take when you ask who won the FIFA World Cup yesterday, it might not give the right results. When is the next concert of Taylor Swift, right? They don't know. The reason being once the training phase has been ended, so they have no clue what is happening with the recent events, right? So it has not gone retrained. So again, don't confuse yourself with ChatGPT or Copilot kind of a chat applications. They are much more than just a LLM model, because if the model doesn't know the answer, so these chat applications use some kind of a search tool to find the latest results and give it to you. Well, we saw how complex it is to build a LLM model from scratch. So let's see what other options we got, right? Fine-tuning a model is one such option. Fine-tuning simply means pick any pre-trained LLM model, off-the-shelf models. It could be OpenAI's GPT model or Meta's Llama, and then prepare your domain-specific data set relevant to your business needs, and make sure the data is high quality and free from any biases. And then you need to set up the environment using any of these frameworks like Hugging Face or OpenAI's fine-tuning APIs, and then train the model using your domain-specific data by adjusting the parameters of this model according to your needs, which is also known as hyperparameter optimization. and you should be very careful during this fine-tuning step, as it may lead to overfitting of the model. So overfitting means if you excessively fine-tune the model to your specific domain data, it may lose its ability to handle general queries like it was doing before. So you may end up completely screwing up the model, and it may start giving some weird answers. So that is why you need to spend a lot of time in testing this fine-tuned model with multiple iterations. And after doing all this, once the fine-tuned model is ready, you may need to deploy it somewhere to start consuming it. So these are some of the risks involved with fine-tuning a model. During fine-tuning, we might expose some sensitive personal information like customer data, which may lead into compliance issues. And we already saw excessive fine-tuning may lead into biased output, and that's what it's called as overfitting of data. Also, over a period of time, as the business evolves, our domain-specific data also changes. So to keep things up to date, we frequently need to retune the model to avoid any outdated or irrelevant responses. So this leads to a lot of maintenance cost. And things about hallucination, we'll see a hallucination in great detail later, but even these fine-tuned models may still hallucinate. Means it can produce factually incorrect or misleading responses, which could harm business credibility. And another security concerns is these fine-tuned models are more vulnerable to these adversarial attacks. Means any malicious inputs can exploit the model's weaknesses. So using off-the-shelf models and fine-tuned models are completely on the two ends of the spectrum. So if you see here, on one side, It's very easy to set up and use pre-trained model, but it lacks the knowledge of our business domain data. But on the other hand, we can fine-tune a model on top of business data, but it's very hard to set up the entire infrastructure, and there are some risks also involved with it. So there must be something in the middle ground. That's when RAG comes in. So if you see the definition of RAG, so the RAG, the Retrieval-Augmented Generation, is a technique of enhancing the large language models by making them to answer questions about data which they haven't trained on. So by fetching or adding relevant documents as a context to the prompts being submitted to a sounds complex. Let's break it down. So here we are not just sending user queries to a LLM. Instead, we are augmenting or retrieving relevant domain specific info and sending them together as a prompt. So this RAG utilizes all the capabilities of pre-trained LLM, like understanding the natural language inputs. For example, user calling a customer care support, like they don't have to say specific words to match the right department. They can express their problems in a more natural way, but we can still answer those queries because now we are introducing a RAG on top of LLM. So with RAG, we can handle any common sense questions as well, like by extending all the abilities of a LLM to follow the instructions. And at the same time, we can augment relevant knowledge of our private data. So this greatly avoids the hallucinated answers. So soon we'll see coding example of how we can build this RAG pipeline with just few lines of code. So to better understand RAG, we need to know about these basic components like vector store, chunking, hallucinations, and how can you avoid hallucinations by using the right prompting techniques like few-shot, chain of thought, and React. So as we saw in this diagram earlier, a vector store is a specialized database that stores and organizes data as numerical vectors. So these vectors are created using embeddings as a way to translate data into a format that AI can understand. So maybe it's a bit confusing now, so let's get deeper into it. So if you want to search for a given word in a database, so you usually go for SQL, right? So you query for something in database. But if you want to search some text in a large data set of files with various file formats, so can we do the exact string match? I don't think so. So let's see why can't we just use an exact string match? The issue with string match is we cannot do semantic search. So what I mean is here is like we cannot search for words with similar meaning. For example, some users can prompt for a plane and somebody else can ask for a flight. They are kind of both similar and they are semantically both means the same, but we cannot retrieve the right documents if you are using something like an exact string match. So that's why, like, as LLM supports to prompt for anything in a natural language, so we should consider for semantic meaning. Again, some more examples to get some clarity here. So if some users are asking for questions like, I am visiting Japan, what's the best plan to get around there? And some might just ask like transportation options in Japan. Some might ask, I want to save money for retirement, where should I start? Versus retirement saving plans. Some user queries could be very descriptive, like I am traveling to Mexico, what phone plan should I use? Versus just asking international plans in Mexico. So that's why we need a vector store that is created from these embeddings or representation of the input text. It represents each word as vectors in a higher dimensional space. So due to this, we can retrieve the embedded vectors that are most similar to the embedded query. So if you are from a programming background, you know these vectors are nothing but just an array of numbers. So in this case, like it's an array of coordinates. So you might be thinking, what the hell is this embedding? So let's get into it. These embedding models creates a vector representation of a piece of text. For example, New York is represented with these numerical vector embeddings. So this is nothing but just a representation of New York in a high dimensional space. So these are the coordinates required to point New York in that high dimensional space. So Paris is represented with these coordinates and animal and horse are like this. one thing, if you observe here, New York and Paris are represented very close to each other, whereas animal and horse are very close to each other in this vector space. So words with similar meanings end up appearing very close to each other in this vector space. So this is why vector embeddings is so useful, because it means we can think about text in this vector space and do semantic search when we look for pieces of text that are most similar to each other in this vector embeddings. Still not clear about vector embeddings? Let's see some more examples. I know it's hard to visualize higher dimensions, so let's try to understand how vector embeddings looks like in 2-dimensional and a 3-dimensional space. So we need these coordinates to represent king, man and woman, and these for apple, banana and orange. Again, in this 2-dimensional space, words with similar meanings end up next to each other. All human beings are in this space, fruits are in here, and all sports related words are represented here. If you go to 3-dimensional space with x, y and z axis, now we need 3 coordinates to represent a given word, and they look something like this. Similarly, if you are going for higher dimensions, like in this case 7D, we need 7 coordinates to represent a given word, and words with similar meanings again are very close to each other. Here is a very good tool for visualizing these vector embeddings. So they have represented these 10,000 words in a 200-dimensional space. So if I search for any word here, for example, let's say bread, it shows all the words related to bread near to each other. So if you see here, it's showing the nearest points like wine, meal, vegetables, cheese, etc. It's a nice tool to visually understand vector embeddings by playing around with different words. I will mention this link in the description below. So now that we got all our domain-specific data, how can we load and create such vector database? So similar to ETL things like extract, transform and load, you can load, transform and embed using any of the embedding models available and store the results in the vector store. So for better performance and for better context, we need to transform the data into multiple chunks, and there are various techniques for doing this chunking. We'll see that in a bit. So also nowadays we can choose from various third-party cloud providers for creating such vector stores and host it in their infrastructure. For example, open source options like Wavy, and for lighter workloads you can even choose in-memory stores like Redis. So here are some of the well-known vector databases available. In a bit, like we'll use Phase library from Facebook to build our own vector embeddings in our coding sample. So once we build this vector store, we can start consuming user queries. Even user questions goes through the same embeddings, and we can retrieve more similar meanings out of it. So let's see a demo now. Here we are using Python to build vector store, and we would need to install a couple of these libraries like LangChain for orchestrating multiple AI tools together, and we are using Chroma as our vector database for semantic search, and so we'll use embedding models from OpenAI. Sorry for interrupting in the middle of this video. If you are still watching this content, please consider liking and subscribing to this channel. It really motivates me to keep creating such videos. Thank you so much for your support. Alright then. So let's see this example of creating a vector store and retrieving the relevant documents from a query for a given query. So in this sample application, this is we are just using very minimal set of documents, and we just have just one module, and you would require these dependencies. And if you are running this as a separate application, you would need this setup, like you have these requirements txt file and add these dependencies here, write your code here in one of the module. But if you are using like Collabs or Jupyter notebooks, you don't need to follow this. Like you can just have the npm pip install as a command there, and then start having all the code there. So you don't have to set up this in any IDE. But yeah, so just to show you here, this module has this main module has this couple of subsections, in a sense like few methods to load the environment first. So this load environment picks some of the environment variables required for running this sample app. As we are using OpenAI's embedding module, we need OpenAI's API key. So to get this API key, you might need to log into OpenAI's the developer platform and sign in there and create a API key. I guess you would also need to have some credit to use their module, like any of these modules. So and the LangChain API key, I think this is free. You don't need to pay anything. But yeah, for OpenAI, you might require to have some credit added to your account. So this is just like loading all these API keys to your environment variable. So once this is done, so what we are trying to do is like we are creating like a document collection. So what this is doing is so we have this bunch of documents, and this is again very sample minimalistic documents. So we have few text here and having some metadata which says which source it is from, and we have a couple of documents related to mammals, some are from fish, bird, and a few of the documents also from electronic related goods. Once these documents are ready, like once you create this collection, so we use that documents to initialize our vector store. So as we mentioned, like we are using Chroma for creating our vector store. So we use this Chroma to create vector store out of these documents, and we are using these embedding modules from OpenAI. So we are providing embeddings from OpenAI, and again you can do many other embedding modules here. So once the vector store is ready, so what this does, so it picks all the documents, and as we learned before, so it creates these high dimensional space for all the words within those documents and create the vector store ready for you. And once this is done, once this is ready, so we pass queries and we can start consuming relevant documents from this vector store. So this function or method here, we are just passing a query and we are passing the vector store here, and it takes those and gets the similar results from the vector store. So just we are passing the query here, and this K is just to tell that how many documents, relevant documents you need it as a result, and we are just taking the top 3 documents from this vector store. Again, this happens to be like we can also, there are other ways where we can return based on the relevance score, and there are multiple things. But to start with, you can have this vector store dot similarity search and pass the query, and it gives the results. And in this example, just like we try to query for a bunch of multiple samples here, but we can you can just start with one of the query. For example, here, so I'm just trying to query for a cat within those, for all those documents in the vector store. So let's see what does we get. So if I have already installed all my dependencies, so I don't need to go with the pip install. So I can just run this main module. So I have Python 3 main.py. So if you see, it is trying to create the vector store first. So once the vector store is created, so we ask for the cat, and we get all the relevant documents. And the first document, we got the one where cats are there in that document, and then we get next relevant one with dogs and other things, and we got some more with the rabbit as well. But all of them documents are related to a mammal. Suppose if I search for, let's say, a friendly pets. So let's see what does it gets. So let me clear this and run it again. So now this time we are querying it for friendly pets out of those documents. And we got, interestingly, we got dogs here, and then goldfish as well. And we got cats as well. So that's how it is. Like it's trying to get the relevant documents out of it. And we can also, there is what I tried is like in this search. So there is also another way to get the results from the vector store. So this is with like similarity search with score. So it will also tell you what is the score based on the relevancy of the query and documents in that vector store. So if I try this time, maybe let me try querying for something else, maybe gaming TV or something, because we have some electronic goods related documents as well. Let me clear this and run it again. Okay, it's again creating the vector store, and for gaming TV we got all the electronic related documents, gaming, and here is the relevancy score for those as well. And one thing to notice is like this creating vector store need not be happening every time. I think this is a sample toy application, so it's fine. But you can have these 2 modules or subsections could be offline. Like these could be anything. You would have these vector store ready, or like maybe it's there already available in your in-memory cache or somewhere, and you also maybe there are vector databases now, so you can create these vector stores offline with all your documents and just write a API which just takes the query and gets the similar results out of it. So yeah, I think this is a quick demo on how to create a vector store and get the results out of a vector store. So that was just a toy example to understand vector store with some sample documents. But we all know that in real world, our documents tend to be very large, and we have to transform this into splitting into multiple chunks for better performance. And another reason for chunking is these pre-trained LLM models has limitations on the context size. So we cannot just copy paste the entire textbook into this input prompts for the LLM. So each of our input prompts are converted into tokens by these LLMs, and there is a maximum limit to it, and this limit varies from models to models. That's why we have to go for chunking the documents into multiple pieces. Again, a crude way is to split the text into fixed number of characters. So let's say if we create equal chunks of 50 characters, the problem with this approach is it may break the word, something like this. It might happen if we are using for character chunking. So that's why many prefer recursive chunking. Here we first break the entire document into paragraphs. So if each paragraph is still large, we'll then break it into multiple lines. And if each line is still large, and again we can break it into words. So this goes on, and here we get better chunking without losing any of the meaning in between. So another approach would be to chunk with some overlap. So this can better improve the performance of the chunking by having some continuity in between the chunks as well. So here is a very good tool where you can play around with chunking. So you can enter some text here and choose the splitter type as character splitter or recursive character splitter. So let's say if I choose character splitter with a fixed chunk size, it ends up splitting between the words, right? So if you see here. So, but here we can provide the overlapping size to improve the context. So if I select this, yeah, it starts now showing with some overlap between the chunks now. So to get some continuity. But when you choose the recursive character splitter, so it better, if you see here, it better creates the splits without breaking any words. So next we'll understand how important it is to follow some of the guidelines while scripting your prompts to LLM. Because while building RAG pipeline, we still need to prompt a LLM by embedding both our domain-specific content along with users' input questions. So the way you create this RAG prompt template matters a lot. So each prompt consists of these three distinctions like instructions, context, and the input data. Because during training of these LLMs, they are trying to follow these structures. Like with instructions, like you can specify a task or a set of instructions that we want a model to perform, and with the context you can specify some additional context or external information that can steer the model to generate a better response. And finally, we provide the input or the actual question that we are expecting out of an LLM model. And it is not actually necessary that we should always follow this syntax kind of thing, like every time we prompt. So it is not like hard and fast true. Like if you see these examples, in this case, like we are just asking the input like the sky is, and we are expecting LLM to complete the sentence for us. And the LLM clearly understands that this is a text completion task, and it goes ahead and predicts the next possible word after this. And the answer we get is the sky is dark and full of twinkle stars. Also, as these responses are probabilistic, we cannot expect the same answer if we ask it again to ChatGPT. Like it might not give the same answer, and also these answers may vary if you are trying out with different LLM models. And if you see in the second example here, along with the input data, we are specifying the instructions as well, like classify the text into neutral or negative or positive. So this is the instruction, and then we are giving the input in the sense like we are clearly asking the LLM to provide the sentiment of this text, like I think the movie was okay. And it's like it correctly gives the exact sentiment of this text, right? It says it's neutral. In the last example here, we are mentioning all the components of a prompt like instructions, the context, and the input question. So if you just see here, like we are providing instructions as answer the question based on the context below. Keep the answer short and concise, and respond unsure about the answer if you are not sure about the answer. So, and that is the instruction. And then we set the context like mitochondria are often referred as a powerhouse of the cell because they generate most of this energy, cell's energy, in the form of blah 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 blah. And then we are asking why mitochondria are called the powerhouse of the cell, and we get the right answer here. So, and as we went through all the proper structure here, like with instructions and then setting the context and the actual input. Let's understand some of these prompting techniques like zero shot, one shot, and few shot, and there are some more. So most of these LLMs perform really good even if the prompt doesn't contain any examples or demonstrations. So that's why we call this as zero shot. So, and this technique works really good for most of the common sense questions. So if you see in this example, we are asking where is the tallest tree in the world, and it gave the right result. But for complex tasks, zero shot may not be enough. As these LLMs are tuned to follow instructions, providing few demonstrations in the prompt really helps the model to understand the pattern and perform really better. So if you see in this example here, we are providing few demonstrations before asking the question. And again, you don't need to provide these number of demonstrations in the few shot prompt. So one or two is sufficient. There is one more prompting technique known as chain of thought. Sometimes even few shot prompt may not help LLM to arrive the right results. So if you see in the first example here, we are asking LLM along with some sample answer. Here we are demonstrating that if there is a question like Roger has 5 tennis balls, he buys 2 more cans of tennis balls and each can has 3 tennis balls. So how many overall tennis balls he has now? We are just saying the answer as 11. Then we are asking more similar question as like and the cafeteria had 23 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? It gave answer as 27, which is wrong. The right answer is 9. But if you see in the second example here, we are not just providing the answer. So we are helping the model to follow these step-by-step instructions to arrive the right result. So in the demonstrated answer, we are clearly mentioning as Roger started with 5 balls, 2 cans of 3 tennis balls each would be 6 tennis balls, and overall it is 5 plus 6 equals 11, so answer is 11. So now it's able to follow this pattern and arrive at the right results. So that's why this chain of thought technique really helps the model to reason in a better way. And if you see here, even sometimes just telling the model to think step by step while answering the prompt also helps LLM to give the right result. Though chain of thought technique helps LLM to reach the final conclusion by listing the reasoning steps, it still lacks access to the external world. So that's where React comes in. So here LLM generates verbal reasoning traces and actions for a given task, similarly the way our human brain thinks. Unlike chain of thought, React internally makes multiple calls to LLM to consume the output of various tools like Google Search or Wikipedia, etc. So if you see in this example here, with React, LLM is going through a series of thought, action, and observation steps before concluding the right answer. So next, let's say about hallucination and why these models tend to hallucinate and how can we avoid these. Hallucination is nothing but LLMs generating factually incorrect or nonsensical responses. And most of the time, the answer is totally not related to the input prompt. The main reason these LLMs tend to hallucinate is their probabilistic nature. And anytime if they don't know the answer, they tend to make up something really nonsense. So though it might look correct, but actually they are wrong. If you see in this example here, so we are I think you might have seen in many online videos here, like when people ask how many M's in a word weather or how many R's in a strawberry, it's not able to give the right answer. Though the question looks very simple, it says like there are 2 M's in the word weather, which is wrong. And then if you ask follow-up questions like where are those indexes of M's, and again like it's giving wrong answers, and it's saying like the indexes are at the first index is at 3 and the second index at 5, and if you say like are you sure, it's like it apologizes, like it says I'm sorry, but it's still continuing giving the wrong answer. So one of the reasons that it could be happening in this case is our input input prompt goes through this series of tokenization, because the LLM model understands these natural language in terms of tokens, and as most of the time they use subword tokenization, this whether word could have been divided into multiple tokens. So that's where, like, when as a whole, it doesn't understand how many letters in that word whether. Here is a well-known Bing hallucination example that happened somewhere in Feb 2023. So somebody asked Bing that when is the Avatar movie showing today? Due to the knowledge cutoff limitations of LLM, the model is not aware of any of the recent event that happened. So it started hallucinating, and it get confused with the dates, but it's still producing wrong responses. And it gets really funny, and the conversation goes on, and finally it became aggressive, and it says like, I'm sorry, but I'm not wrong, trust me on this. And finally it says, I'm sorry, you have lost trust and respect, you've been wrong and confused and rude. So it's it can go really bad, like these hallucinations, if it is not properly handled and validated while training the model or during fine-tuning. The hallucination is like tend to happen most of the time. So to avoid hallucinations, there are many techniques. First is providing the right instructions. Things like asking LLM in the prompt that answer I don't know if you are not aware of this prompt. And next is training LLMs to have packed validation steps with the external sources. Like every time you train the model or retune the model, it's always better to have some kind of validation steps to validate your end results with some external sources. Like they call this as grounding. And another is like providing the right context is very important in the context of an LLM. It's like the way you provide the context or the conversation history really helps the model to understand the question that you are asking. And using advanced prompting techniques like we saw, like the chain of thought and React, also helps these LLMs to eliminate hallucinations in their output. And finally, conducting extensive adversarial testing before releasing the model for public use is always very helpful to avoid such hallucinations. So let's see a quick demo of how we can build a simple RAG on top of some construction domain data. So similar to the way we built a vector store last time with some dummy documents. So this time, like we'll use like sample text file here. So it has few like domain specific data related to the construction, like building foundations, concrete mix rates, and some safety measures and all that. And in real world, this could be like a huge PDF files or some CSV files or something. And so just for testing, we have picked one sample text file here. Yeah, you would need some of these dependencies again, along with LangChain, using the same OpenAI's embedding model. This time we are using Phase for creating the vector store. Yeah, so let's go into the code here in the main.py. In the main module here, like this time we are creating a class to make it things very clear. So we are creating an object of the construction RAG, and this class has a few steps. So during initialization, like it reads all the environment variables from this env file and loads it, and it uses all the LLMs wherever. I think we are using here we are using OpenAI's LLM and OpenAI's embedding model as well. Let's see here, like once the construction RAG is created, you can start loading the documents from this path. So here, as we have some text files, so we are loading the documents. So what this load document does is it reads the files from that path and it creates the document out of it. And it also, if you see, we saw earlier this chunking, and we are using recursive character text splitter here with a chunk size of around 100 and with the overlap of 50. This is to have better context. So we are passing that to a recursive character text splitter, and we split those entire document into multiple chunks. And once those documents are ready, we are then creating the vector store. So we are using Phase again to create the vector database out of these documents. So this create vector store method is it's just using the Phase library, and we are passing the documents and the embedding model from OpenAI. So once these are done, our vector databases will be created out of these documents. And then we are setting up the RAG chain. So this RAG chain, like it needs a vector store, and we are coming up with this prompt template. So we are providing the instructions. If you see here, we are saying you are a construction domain expert, answer the following questions based only on the provided context. And we are also saying that if the information is not in the context, just say I don't have enough information about the current knowledge. So this actually helps to avoid any such hallucinations in the output. And this prompt template has this context and also the input. So this context is coming from our documents. Like whenever we run through the LLM with this prompt, so the context is taken out of the documents, and we are also taking the user input and dynamically passing here in the prompt. Once your prompt template is ready, so then we take that and we create the document chain and the retriever chain. So for creating the document chain, so we need the LLM and the model. We pass the prompt and also the output parser. So and then we create the retriever out of this vector store. Once this chain is ready, once we set up the RAG chain, then we start using that chain to prompt for questions. And here we are just having this infinite loop to and allowing users to ask for questions until they hit quit. And in this query, if you see this rag.query, where we are passing this RAG chain and with the question which user is asking. So this query, all it does is it invokes that chain by passing the user question here as an input. And this input is passed here as a template which we saw earlier, along with the context that is coming from the documents. So together, the context of our business domain and the user input is going to the LLM to generate the output. So let's run this simple RAG, for example. So if I run main.py, let's see. It created the vector store as before, and it is able to set up the RAG chain, and it's ready to take the questions. Let's ask something which is related to construction. So we are asking what are the different types of building foundations. And it generated correct answer. Like it's saying there are two types, like shallow foundations and deep. And there are again within the shallow, it includes this footings, strip foundations, and raft. All that it's coming from this sample text that we have seen here. Like going through the text here, and is able to understand what this says about and able to summarize in a nice fashion. And if I ask one more thing, like what is the ratio for the concrete mix, and it exactly gives the right answer. Like in the sample text I have seen here, we are mentioned somewhere that standard concrete mix is this ratio for cement, sand, and aggregate, like 1:2:4. Able to get that. And if I ask something gibberish, it's now, if it doesn't know the answer, it's not hallucinating. It's saying I don't have enough information. That we set that up in our instructions, right? So that's why having the right instructions is really important to avoid any hallucinations. And we have to properly test if it is giving the right results. So to take things further, so I created another sample application. So here, instead of using some sample dummy text, so I started using datasets from Kaggle, which is a kind of some construction related report CSV file, which has around 2.2 MB worth of data. And I downloaded a few of the PDF files, which has few construction guidelines and safety measures. So this is this is one, and there is one more here. So these are has a lot of data related to the construction industry, including loading the documents now. Instead of just using the sample text, now this is taking all the PDF files. So once the documents are ready, I think we already saw I did the same text splitter, creating the chunks, and then created the vector database using phase and come up with this prompt template where so we are providing proper guidelines to the LLM and having dynamically adjusting the context and the input. So we're also asking LLM to mention some of the references in the output, like maybe the page numbers in those PDF files, and anything that it's referencing. It's better to have that in the output. And so this is all same. And one thing is, in this sample application, like I tried with the Gradio. So Gradio, it helps you to create a nice chat interface. So in the last demo, in the other application we created a sample like a kind of an infinite loop of asking questions where you have to try out these things in your terminal. But instead of doing this, like, you can also use this Gradio, create the chat interface out of it. Once this chat interface is ready, you can also provide a few sample examples to start with, and it will also accept the user inputs as well. So once this setup is done, you can run this application again even in local. You can so it will create a nice interface for you in your local host. But I tried deploying in Hugging Face because others can also access it. So here, so I hosted this application in Hugging Face. Like, you have to just create a space. I think there are a few steps. Maybe you can find in their API documentation. So once it's running, like, if you see, this is the interface from the Gradio with a chatbot, and you can ask any questions. Like, these are the samples, and I asked on one of this, like, what are the key safety measures required while working with the heights. So it's going through all that documents. If you see, it's now referencing even the answers from those documents and able to give you the answers. If you see the logs, it's loading all the PDF files and as well as the dataset from the Kaggle, the CSV files which we saw. So once all these files are there, it's now creating the chunks for those files, and then creating the vector database for those documents. And once vector store is ready, it's now able to accept any questions related to the construction domain. Okay, so I have uploaded all the code files in this my GitHub repository, and I will mention this link in the description below. So you can just play around with that and maybe try to change the domain, like the domain specific data with your interesting business domain, and you can try it out. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and consider subscribing to this channel. I would love to hear your thoughts and suggestions, so leave a comment below and feel free to share this video with anyone who might find it helpful. See you in the next one. Take care and happy learning.